So for this one, we're proving that we have a parallelogram, because we're given two pairs of parallel lines, so this is a parallelogram that's cut diagonally into two triangles. So we have to prove that the two triangles are congruent so that we can prove that one of the pairs of opposite sides is congruent, which is actually a property of parallelograms, and so this is how you prove that property of parallelograms. So obviously you start with your given information. We have two pairs of parallel lines. We don't have any bisectors or midpoints. We do have a shared side, so that's going to be useful. Segment RT is going to be congruent to itself by the reflexive property. So mark off in your diagram the parallel lines. Parallel lines you mark with little arrows, congruents you mark with little tick marks. Be careful not to mix those up because it's very easy at a glance to forget what's supposed to be congruent and what's supposed to be parallel. So make sure you're paying attention when you're looking at the diagram. So we've got a pair of sides that's congruent by the reflexive property. Now we need to go we have parallel lines. So now we have to use those parallel lines to find the angle pairs. So we've got RS gives us, so you use RT as the transversal. So RS gives us this little Z shape, and whenever you have that Z shape, it gives you alternate interior angles. So this angle here, angle SRT, is congruent to angle UTR because they're alternate interior angles. And now we use our other pair of parallel lines. And we do the same thing, except this time we use the little N shape. So now we take these corners and say that they're congruent to each other. So that's angle URT and angle STR. So now we've got three pieces that are congruent. We've got a pair of sides and two pairs of angles. So we can say that the triangles are congruent. Now in the proof, it says side, angle, angle, but if you look at the actual triangles, the side is connecting the two congruent angles. So it's really angle, side, angle. We don't have a triangle congruent statement given to us, so it doesn't matter how you set up the triangle congruent statement. You just have to make sure that the second triangle matches the first triangle. So if I want to call it triangle SRT, then I have to call the other one triangle UTR. If I want to call it triangle URT, I have to call the other one triangle STR. You can put the first triangle in any order because you don't have a statement that you're told how to set it up, because we're going on to use that triangle congruent step to prove the other pair of sides that we don't have yet. So once you prove that the two triangles are congruent, then you can take any other pair of sides or pair of angles and say that they're congruent by CPCTC, because corresponding parts of congruent triangles are congruent. So if you know the congruent triangles, you can name any other pair of corresponding parts. Okay, so now we showed that the pair of sides is congruent. So the opposite sides of the parallelogram are congruent. You can use the same reasoning CPCTC to show the other ones if you wanted to prove the property that both pairs of opposite sides of the parallelogram are congruent.